Now, R is a good measure of association if the scatter plot has linear association and is homoscedastic. If it's heteroscedastic, I mean here, if I just look at this, it looks like the best fitting line ought to be horizontal, right? There's sort of no real trend here. But because of the heteroscedasticity, this one point up there is having a pretty strong influence on the line that I would fit if I fit it by least squares, which we're going to get to pretty soon. And as a result, the correlation coefficient is, pretty different from 0, even though, this is not very strong association, right, visually. Does that make sense? Okay, so if you have heteroscedasticity, the correlation coefficient is not a very good measure of association. If you have nonlinearity, the correlation coefficient is not a very good measure of association. If you have outliers, the correlation coefficient is not a very good measure of association. So here, for most of the points, knowing the value 1 isn't telling you much at all. But because there's that one point way over there, that has huge influence on the correlation coefficient. If you fit a line to this, the line would have positive slope. It would do a very good job of predicting the value of that point compared to a horizontal line. And as a result, the correlation coefficient ends up being big. But an outlier can also kill the correlation. So here, if you ignore this point, these points come very, very close to lying on a straight line. But I throw in this one outlier, and it knocks R down to 0.08. Okay? It just has a very large influence on the correlation coefficient. So if you have nonlinearity, heteroscedasticity, or outliers, the correlation coefficient is not a very good summary of the association.